Okay, next one, we're talking about springs. So a spring that can be elastically deformed means that it can return to its original shape. But if it's inelastically deformed, once you punch it, so if this person was to punch that piece of wood, it will not go back to its original shape. That is inelastically deformed. Now, how springs work is that first, when you apply pressure to it, you are now giving the spring elastic potential energy. So it's gaining elastic potential energy. Then when you release the spring, all of that elastic potential energy is now converted into kinetic energy, which is why the spring moves back up to its original shape. So first you squeeze it down, you give it elastic potential energy. Then when you release it, that elastic potential energy converts into kinetic energy. Okay, with springs we have this really important equation that goes like this: force equals spring constant times by extension, and all of those values have different units, so make sure you memorize those. How do we use that to explain if a spring is stiff or if it's quite elastic? Now, the way we can do that is the following. There are two ways actually. The first way is the following: if a spring has a large spring constant, so if the K value is large, that means that that spring is very stiff, so it's very hard. So it means that you're going to put a lot of energy into it, try and compress it, but it's not going to move much. If K is very small, that means that's a very stretchy spring. So, or you can say a very springy spring, basically. That means you put a little bit of energy and all of a sudden it squeezes or it pulls up a lot. So how can we prove that in terms of mathematically? We can say the following. Imagine we have two springs. Okay, so spring A and spring B. Now, spring A, I'm going to, both of the springs, I'm going to try and compress them. For the first one, I use 10 newtons, and it extends by let's say, 2 meters. The second one, I'm going to use 10 newtons, and it extends by 5 meters. So, work out K for both of them. So, remember, we're going to use the formula F equals KE, and K is equal to F over E. So K for this one is going to be F, which is 10 over E, which is 2. So that gives you 5. And this one, K, is equal to 10 over 5, which is 2. So, of course, we can see that this one, the spring over here, did not extend as much. So it was quite stiff, and therefore it has a much higher K value. The spring on the right, on the other hand, extended by 5 meters, so it was much more springy, and as a result the K value is much more smaller. Okay, now that's one way you can tell. Another way is that if you have a graph like this where you have extension on the x-axis and force on the y-axis, for all springs it will be proportional, so it will be a straight line up to this limit. This P stands for limit of proportionality. Beyond that, you can see that it curves off. So our equation where F is equal to KE, that equation only applies from here all the way up to the limit of proportionality. So beyond that, our F equals KE equation does not apply. Okay, now the next part. Remember, we said K was equal to F over E. Now in this scenario, if I do F over E, that's going to be the same as doing Y over X. And we know Y over X is the same as a gradient. So basically, the gradient of this line is equal to K. Now, if you have two springs, let's say they ask you to compare. So that's one spring and here's another one. So we'll call this one spring A and we'll call this spring B. And they ask you to compare which of these two springs is stiffer. Well, we can see that spring B has a larger gradient. And remember, we said that K is equal to the gradient. So spring B has a larger value of K, and therefore if K is larger, it will be a stiffer spring. Now, the next one is a practical of how we can produce this kind of graph. To do that, we're going to first have this set up where we have a clamp, clamp it with a ruler, have your spring and some masses. And what you're going to do is you're going to add the masses and record the extension. So you're going to keep on adding masses each time, and you're going to record how much it extends by. Once you've done that, you're going to plot your on the x-axis, you're going to plot extension. On the y-axis, you're going to plot force. And eventually, you should see something like this. Again, if they ask you to find the limit of proportionality, you can see that it's somewhere around over here. Because beyond this point, it begins to curve off. So that will be P. So again, the practical, this is how you would mention it in your exam. Now, once you've done that, they could ask you to work out how much kinetic energy the spring has gained. So, for example, they might say, okay, let's say that the spring has extended to 10 centimeters, or 10 meters rather. And so at this point, how much elastic potential energy, how much energy has the spring gained? So what you'll do is you'll go up to the line, and from here, you're going to read force. And so let's say the force was, 5 newtons. Okay, so 10 meters and 5 newtons. So once you've got that, you can do two things. The first thing you're going to do is you can use this equation to work out energy. And the way you can do that is you're going to write half times by K times by E squared. So for this particular one, E obviously is 10. So we're going to do half times by K times by 10 squared. Now, where do we get K from? Remember, we said K was the gradient. So I've got a little triangle right now, right here. I've got a line, sorry. I can work out the gradient of that line. What's the height of the triangle that I've produced? The height of this triangle is going to be 5. What is the width? The width is 10. So all I have to do is do 5 divided by 10. So that gives you 0.5. That's my K. So I can put that into here. So I'm going to do half times by 0.5 times by 10 squared. And from that, I can work out how much energy the spring has gained. Now, another way you could do it is just literally work out the area of this triangle. So again, to find the area of a triangle, the formula is half times by base times by height. So we're going to do half times the base. What was the base? It was 10. The base was 10. And what was the height? The height was 5. So I'm going to do that. And that should give me the same value. So there are two ways to find energy of a spring, either using this formula or by working out the area under the triangle.
Hey guys, if that video helped you, support our channel by liking, subscribing and sharing it with your friends. And more importantly, if you still have questions, drop a post on our forum at ExamQA.com, where I will personally be there to help answer your questions. Mohammed signing out.